All right, so this video is meant to go over the aspects of polynomials that we've been doing this week and just a nice little review for you. So the first thing I'm going to have you do is think about each one of these functions, f of x, and decide for yourself if this function is a polynomial. If yes, write yes. If no, write no. So to help you get started, I would say that this f of x is not a polynomial because we have a negative exponent. But I would go ahead and say that this this function is a polynomial. I should follow my own directions and write no instead of not, huh? Is a polynomial because we have positive integers as our exponents. So go ahead and pause, decide yes or no for each one. Pause your video now. All right, hopefully you did okay with that. So I circled the things in red for why we don't have a polynomial. This one we have a root, this one we have a variable in the denominator, and this one we have a variable in our exponent. All right, next thing we're going to do is list the degree, the number of terms, the end behavior, and the leading coefficient. So remember, for the degree, you're looking for the highest exponent. So this one would have a degree of 5. The leading coefficient that goes with it is 3. I have 1, 2, 3, 4, 5, 6 terms. Let me clear that. Oops, this should be a 5. This should be a 3. I had 6 terms. And my end behavior, because I have an odd degree with a positive leading coefficient, my end behavior is going to be down, up, because my ends are going to do something, might have a bunch of turns in between, like that. So go ahead and pause your video. Try the degree, leading coefficient, number of terms, and end behavior arrows for B and C. Pause your video now. Go ahead and check your answers against mine, see how they went. Remember, your end behavior arrows are always based off of the degree being even or odd, and the leading coefficient being positive or negative. All right, our next skill to review is how to evaluate a polynomial. Remember, evaluating means your final answer is going to be a value. So if I want to evaluate this function when x is equal to -4, that means f of -4. Every time I see an x, I'm going to replace that x with a -4. Then I'm going to carefully follow my order of operations. So f of -4 equals -4 squared is going to be 16 minus 24 plus 5. So f of -4, 16 minus 24 is -8 plus 5 is going to end up being -3, which means that we know the value when x is -4, y is -3. Okay, go ahead and pause your video. Try part B for yourself. All right, so everywhere I saw an x, I replaced that x with a 2. Carefully following order of operations, parentheses first, got me the 32, the 8. The next thing that I did was my multiplication. So 3 times 32 was 96, 2 times 8 was 16, 12 times 2 was 24, kept the negative, and then 4. Then I went through, combined 96, added 19, lowered by 24, added 4. My input was 2, my output was 92. All right, next thing to revisit, okay? We're actually just going to focus on 4a for right now. We're going to talk about 4b in a little bit, but 4a says distribute the polynomial, graph the polynomial, find the x and y intercepts. Well, we do want to distribute the polynomial. So f of x, I'm going to do x squared plus 3x minus 2x minus 6. Combining like terms, my distributed polynomial will be f of x equals x squared plus x minus 6. All right, well, we're supposed to graph the polynomial. So if I think about this, my end behavior, I have an even degree with a positive coefficient, so I know my ends are supposed to be up and up. My x-intercepts are going to be based off of these factors. So x minus 2 needs to be equal to 0. That's going to give me an intercept of 2. And then x plus 3 has to be equal to 0. That's going to give me an intercept of negative 1, 2, 3. My y-intercept is what happens when I find f of 0. So when I plug in 0. So if I plug in 0 squared plus 0 minus 6, f of 0 is equal to negative 6. 1, 2, 3, 4, 5, 6. And I could do more. I could get my vertex. I could get a few more pieces of information. But I know that my axis of symmetry is supposed to be halfway between my zeros. So I can predict that my parabola, my low point should be somewhere around here. Have my up arrow and my up arrow. And we can revisit this looking at our graphing calculator if we needed to. And that's what we're going to try to do for part B. We're going to get as much information as we can, but then we're going to end up relying on our calculator. All right, so through the power of movie magic, I have done as much as I can without my calculator. And you can write this down if you want to, but actually I'm going to tell you that part B we're going to come back to and revisit in some videos next week. So don't stress about it. If you're running short on time for today, you can skip this problem, but also wouldn't hurt you to write it down. So I distributed out all of my first, outside, inside, last. X squared times x squared got me x to the 4th. Combined my like terms, found my y-intercept. Then I went through and I tried to find my x-intercepts and I kept getting these imaginary numbers. So I jumped to my good friend Desmos. And in looking at Desmos, I typed in my function. And what I see is something that looks like a parabola, but if I zoom in really close, something kind of interesting happens. Where my vertex is supposed to be, I definitely still have a vertex, but compared to a parabola, x squared, just type some things in here real quick, 3x plus 2, as opposed to a parabola that's been shifted up 2, trying, x squared plus 2, there we go. As opposed to a parabola that's been shifted up 2, this has kind of a different shape to it. And we're going to get into that shape a little bit more for what that means and what that looks like next week. So for right now, we know we should have our positive, even end behavior. You can go ahead and give yourself just kind of a wider parabola, if you will. Don't stress about B. It's okay. We're going to come back to it. All right, next one's simplify. We have addition, subtraction, addition. I think that's it on this one. So go ahead and combine your like terms. Make sure you distribute in this negative sign to each one of these. And then see if you can answer each of these questions. Go ahead and pause your video to try, unpause when you're ready to check your answers. All right, so I went through and I distributed. Well, for the first one, there was nothing to distribute. I just combined like terms. My y-intercept is 0, negative 1, because that's the constant value that's on the end. If I were to plug in 0, all of these terms would go to 0. For this one, I had to distribute in that negative to each one of these terms. So I had 2 minus 5 was negative 3, negative 4 minus 6. Miss Schwartz made a mistake. Not the first time, won't be the last time. My apologies. This should end up being negative 4 minus 6, which is minus 10x. And then 3 minus negative 2 gets you 5. Next one, I distributed in the 4. 4 times 6, 4 times 5, 4 times 2. And I distributed in the 6. 6 times 1, 6 times negative 3. Then I combined my like terms that I had and got all of this information. Okay, hopefully that looks familiar to you. We've done a lot of practice now with finding each one of these things in a polynomial expression. Next two are just like the first ones that we did together, so I'm going to have you pause and try these ones. Be really careful with your order of operations. Find me f of negative 2 for the first one, and find me f of 2 for the second one. All right, hopefully you use that calculator very carefully with your order of operations. We get negative 2 comma 24 and 2 comma negative 400. All right, last one. Write an example of a function that would not be classified as a polynomial. So I could write 3 to the x equals g of x. I could write 1 over 5x to the third equals h of x. I could write f of x equals x to the 1/2. I could write m of x equals x to the 4/3, right? Anything that has a fraction exponent, a negative exponent, or a variable in the exponent are going to be examples of things that are not polynomials. All right, that concludes your review video. Hopefully this week went well with all of your different polynomial characteristics and then adding, subtracting, and multiplying polynomials. Thanks for watching.